Look up at the night sky. Each twinkling star is a giant fusion reactor. Stars are powered by the same process we are trying to create on Earth: nuclear fusion. Fusion has the potential to change the world. It promises clean energy, free from greenhouse gases. Imagine a future powered by the same energy that makes the stars shine. Fusion power is not science fiction, it's real science. And it's a goal that scientists and engineers are working hard to achieve. The journey is challenging, but the rewards are enormous. A future with fusion power is a brighter future for humanity. To understand fusion, we need to talk about atoms. Atoms are the building blocks of everything around us. They are made up of even smaller particles: protons, neutrons, and electrons. Fusion and fission are two ways to release the energy stored inside these atoms. Fission is like splitting wood. We break a large atom like uranium into smaller atoms. This releases energy. Fusion is different. It's like squeezing two pieces of clay together. In fusion, we take two small atoms and force them to combine or fuse into a larger atom. This also releases energy. Fusion is the process that powers the sun. Deep inside the sun, hydrogen atoms, the smallest atoms, are squeezed together under immense pressure and heat. This forces them to overcome their natural repulsion and fuse. They form helium, a slightly larger atom. The process releases a tremendous amount of energy. On Earth, we are trying to recreate this process. We use isotopes of hydrogen called deuterium and tritium. These isotopes are easier to fuse than regular hydrogen. When deuterium and tritium fuse, they form helium and a neutron. A tiny bit of mass is lost in the process. This mass is converted into a huge amount of energy according to Einstein's famous equation, E = mc2. This means that a small amount of fusion fuel can produce a lot of energy. For example, the fusion of just 1 gram of deuterium and tritium releases the same amount of energy as burning several tons of coal. And it does so without producing greenhouse gases. Section 5. Taming the Dragon, the quest for fusion power. Creating fusion on Earth is a huge challenge. The biggest hurdle is achieving the extreme temperatures and pressures needed to fuse deuterium and tritium. These conditions are found naturally in the core of stars, but recreating them on Earth is incredibly difficult. Scientists are using powerful machines called tokamaks to achieve these conditions. Tokamaks use magnetic fields to confine and heat a plasma, a superheated gas where fusion can occur. The plasma is so hot, it would melt any material it touches. So, it has to be held in place by powerful magnetic fields. Section 6. ITER, a beacon of hope. The International Thermonuclear Experimental Reactor, or ITER, is currently the world's largest and most ambitious fusion project. Located in France, ITER is a collaboration between 35 countries, all working together to make fusion power a reality. ITR is designed to demonstrate the feasibility of fusion power. It aims to produce more energy from fusion than it takes to heat the plasma. This is a crucial step towards a future powered by fusion. Section 7. A brighter future. The potential of fusion energy. The potential benefits of fusion energy are enormous. Fusion offers a clean, safe, and nearly limitless source of energy. It produces no greenhouse gases, so it won't contribute to climate change. Fusion reactors also produce very little radioactive waste. And unlike fission reactors, fusion reactors cannot melt down. This makes fusion a very safe form of energy. Section 8. Challenges on the road to fusion power. Despite the promise, fusion power still faces significant challenges. Building and operating fusion reactors is incredibly complex and expensive. Achieving a sustained fusion reaction that produces more energy than it consumes is incredibly difficult. However, scientists and engineers are making steady progress. New materials, technologies, and designs are constantly being developed. With continued investment and collaboration, fusion power could become a reality in the coming decades. Section 9. Conclusion: Our fusion future. Fusion power represents a beacon of hope for a brighter future. It offers the potential to address some of the biggest challenges facing humanity, from climate change to energy security. While significant challenges remain, the rewards are well worth the effort. Imagine a world where clean, safe, and abundant energy is available to everyone. This is the promise of fusion power. By unlocking the power of the stars, we can create a brighter future for ourselves and generations to come.